So you've probably noticed that search results are getting way, way smarter, right? Well, the reason why is this fantastic secret that's been hiding in plain sight. And get this, it's not about more powerful computers. It's about a really old school discipline that's teaching brand new AI some very important tricks. Okay, so let's dive right in. We've all been there, haven't we? You type in what feels like a perfectly simple question, and the results you get back are so bizarre, you start to wonder if the algorithm is, I don't know, having a weird day. How can it so completely miss the point of what you're asking? Yeah, this is a classic example of the problem. When a search engine sees the word Puma, it has to make a split-second guess. Are you talking about the big cat, the athletic brand, or that old car model? It has to sift through your search history to figure it out, and there's a fancy term for this in information science, disambiguation. It's literally trying to unconfuse your request. And ambiguity is pretty much the #1 enemy of good search results. As information experts Marcelo Schriesel and Marisa Brasher have said, it's a massive, massive obstacle. So here's the billion-dollar question. How in the world do you teach a machine to cut through all that confusion? So where does the solution come from? I mean, what's really fascinating here is that the answer isn't coming from some high-tech lab in Silicon Valley. Nope. It's coming from a field that's been organizing knowledge for centuries. That's right, can you believe it? The very science of how we organize books on a shelf and how we understand language, that holds the key to helping some of the most sophisticated algorithms on the planet finally understand what we're talking about. And this right here is our secret weapon. It's a discipline called terminology. Now, you can think of it as the science of creating a super precise, standardized dictionary for any expert field you can imagine, whether that's medicine, engineering, or even something like SEO. Okay, so how does this science actually work? How does it create that kind of precision? Well, it all starts with a simple rule. You can't just describe something vaguely. First, you have to know exactly what it is you're trying to define. So in the digital world, we call these things entities. An entity is basically anything, concrete or abstract, that we can pin down and gather specific information about. So the Eiffel Tower, that's an entity. The color blue, also an entity. A specific model of car, yep, you guessed it, an entity. But, and here's where it gets tricky all over again, the big challenge is that the same exact entity can have a whole bunch of different names. This is called terminological variation. And trust me, it creates a huge headache for both people and machines trying to make sense of things. Okay, let's take a medical example to make this super clear. For a long, long time, the disease we now know as Hansen's disease, well, it was known by this term, lepra. And in other places, at other times, it was also called this, mal de Lázaro. Before the medical community finally standardized the term to Hanseníase, or as we know it, Hansen's disease. So you've got 3 different names, but they all point to one single medical entity. An algorithm has to know that they're all the same thing, otherwise, chaos. So how does the science of terminology cut through all this confusion? Well, it's not with some super complex code. It's actually with a really elegant and surprisingly powerful formula for writing definitions. The solution is this brilliant 2-step method. First, you start with what's called the genus proximo, which is just a fancy way of saying you place an entity into its nearest broader category, its family, basically. Then you add the differentius specificus, the specific features that make it totally unique within that category. And check this out. This example illustrates the formula perfectly. An electric car's genus, its family, is motor vehicle. Simple enough. Its differentia, its unique trait, is that it's powered by electrical energy. And boom, that single phrase is what separates it from every other kind of motor vehicle out there. It's just perfect, unambiguous clarity. I mean, just look at the difference this makes. The vague definition on the left tells you what an electric car isn't. It's a car that doesn't use gas. Okay, but the precise definition on the right tells you exactly what it is. For an algorithm that's trying to learn and understand the world, this kind of clarity is pure gold. All right, so why does any of this matter to you when you're just, browsing the web? Well, because today, pretty much every piece of content you see online is being written for 2 very different audiences at the very same time. On one side, you have us, the humans. We're looking for stories, for creative language, for stuff that's engaging and fun to read. But on the other side, you have the algorithms. And what do they want? They crave structure, precision, and absolutely zero ambiguity.
The real trick for content creators today is figuring out how to make both happy.
And when they get it right, the payoff is huge. By using these super precise formal definitions, creators are basically teaching search engines what they're talking about, one piece of content at a time. This means better search results for you, it means smarter voice assistants that can give you that one perfect answer, and it means we're building a web where knowledge is standardized for everyone. And that really is the big picture here, isn't it? This isn't just about gaming the system with keywords anymore. By defining our terms with this kind of care, we are all collectively building a semantic layer for the internet. A web that doesn't just match words, but one that actually understands concepts. It's a pretty fascinating thought to end on, right? What if the future of AI really depends on the ancient wisdom of librarians? It seems that to build the artificial intelligence of tomorrow, we need to go back and rely on the foundational principles of organizing human knowledge that have been perfected for centuries. The future, it turns out, has some very, very deep roots in the past.